So what we're going to begin now is what's called graphing quadratic functions. That means a function that has a square value on the letter. So if right here we have a quadratic. So what we want to do is how can we get our points? Well, if we find x and we can plug it in, we can get what the y is because f of x is really the y value. So I'm going to pick 5 points, and I've already done it right here. If I pick 0 and put it in for x, I will get 6 for y. So our coordinate is 0, 6. I can do the same thing for 1, 2, 3, and 4, and I get my answers as I go through and plug in and do the math. Remember, f of x is the same thing as our y value, and that's where that comes from. So now if I take those 5 points and plot them, which they were all plotted right here, 0, 6, 0, negative, or 0, 6 is right here, and then 1, negative 3 right here, 2, negative 6 is right here, 3, negative 3 is, I already had that one, 2, negative 6, and then we have 4, 6, 4, 6, and 1, negative 1 is right here. So there's those 5 points. If you take those 5 points and connect them with a curve, you'll see we have what's called a parabola. And a parabola is created by points that are not in a line and create a nonlinear equation or a graph. Another way of graphing a parabola or a quadratic equation is using the information of these axes of symmetry, the y-intercept, and the vertex. And so basically a parabola has a middle, which is called the axis of symmetry. That's where this red dotted line. And it crosses the y-intercept, which we've done before. That means where does it cross the y-axis, and it crosses it right here. And then we have the vertex, which is where it actually turns. And that means where is that turn. So here's the vertex. So we can figure these points out by just basically using this formula that we have written up here, x equals negative b 2a. So let's first do what we know of, and that is the y-intercept. The y-intercept is basically making x 0. So if we make x 0, so if this is 0 and this is 0, we're left with negative 3. So the y-intercept is a negative 3. So we have a point that where it crosses. Now we can do the axis of symmetry. And the axis of symmetry is taking negative b over 2a. So our quadratic formula has a is our first letter, b is our second, and c is our constant. So 1 is our a, and 4 is our b, and negative 3 is our c. So if I put this into the formula, I have a negative 4 over 2 times 1, which works out to a negative 2. So our axis of symmetry is at negative 2. What that means is the parabola is going to run along that negative 2 number. It also means that our vertex has the coordinate with a negative 2 as x, which we will use when we're finding our other coordinates. So if we go down here and now use the table, and when we use the table, I want to highlight the fact that we want to use this the vertex x, and we want it as our middle point. So negative 2 is our negative, so we pick a point on the right side of negative 2. So basically, we have an axis of symmetry that's going to run right down this line on our graph. So we want to pick points to the right and to the left of that axis. That's why we pick 0, and that's why we pick 2. And we also pick our negative 4 and negative 6, which are to the left of the axis. And if you do the math of that, you come up with these points. And if we plot those points, negative 6, 9, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. And then negative 4, 3, 1, 2, 3, 4. Negative 3, 1, 2, 3, which is right here. And we have a negative 2, 7, negative 2, 1, 2, 3, 4, 5, 6, 7, negative 2, 7. That's our vertex. And we have 0, negative 3, 1, 2, 3. And our final point is 2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 up here. And then we connect those with a smooth curve, the best that I can here. We have our parabola with the axis of symmetry at negative 2. And our vertex now is this point, which is negative 2, negative 7, which we found when we plugged in right here. into our box, or into our table. So basically, you're going to use the table like we did before and put in points, but now we're putting in specific points. And our first specific point is our vertex, or our axis of symmetry.